Right, so I want to talk about the Feynman diagrams around the matrix, the derivations of the Feynman diagrams coming from the time-dependent preservation theories. The text coming from the contemporary theories because it gives you so much. We know that the amplitudes can be obtained from the broadcast inner product of the broadcaster of the binary size and the initial size in the quantum mechanics. And there will be some of the matrix which coming from the interactions Hamiltonians as the perturbing terms. And the initial starts can be treated as a times go to the minus infinities in the past, and also minus times they going to the reaches infinities, and such initial size and minus size can be interpreted as a size drop, eigensize drop the breeze Hamiltonians, which is an unperturbed part. But such as time evolution or interaction paths are the perturbing Hamiltonians. That is some of the situations. And such as some of the initial and final stages as exact solutions of the non-perturbing paths. And we know that the interaction pictures coming from the quantum mechanics as some of the variations of the Heisenberg picture. In these interaction pictures, the operators are time dependent with the transformations, otherwise the changes, and also quantum size is also the time dependence on the time evolution factors, but there are only unperturbed Hamiltonians as a constant as the time evolutions the pace factor. And we know that the Schrodinger equations can be written like that. There are some derivations in here. The time derivatives of the interactions pictures quantum size are given like that from this definition. And we know that there will be some minus h0s coming from the exponential factors, and the IDT coming from the IDTs such as the time derivatives acting in the quantum size. And we know that such as the minus h0s plus the IDT is equal to the HI. I mean, the IDT is equal to the IH, so minus HGs plus IHs becomes the interacting Hamiltonians. We instance some of the unitary time evolutions applied to instance of the quantum size, and there will be the time dependency Schrödinger's equations for the unitary time evolutions applied to the differential equation, and then we can obtain the solutions as exponential form. So time evolution applied to solutions are given like that, exponentials minus of the integrals of the Hamiltonians of the over the time, and there will be some time ordering for the operators in the interacting Hamiltonians. So such as the solution of the time evolutions unitary operators called the Dyson expansions. So we can expand this sort of this exponential factors as a series expansion form. We can define sort of the matrix, which is a such a time evolution unitary operators with the initial terms minus infinities, and the binary time is the infinities feature. So here's minus infinity to the infinities integral, and such a dt's will be converted to d4x with the Hamiltonian density. And from here, so we will discuss just about some of the constructions, how the such external field and internal fields can be converted to some of the propagators that are some of the contributions of the matrix amplitudes, and that's called the Feynman rule. So we know that some of the periodic quantizations can be written like that as a simple version of such as specific fields is the summations of the creations of operators and annihilation operators. Some preambles with the prime-wise terms that are omitted here. And some products of the two-bit operator can be expanded through with the creation and annihilation operator. And if we give some of the number ordering, which is the creation operator to the left and all annihilation operator go to the right, is for the zero spectrum expectation value. If we act sort of the broadcast with the vacuums, then in the general ordering of the such products of the phase of light, will give the some of the zero values, and is very easier to calculate sort of something sort of the products of the phase of light. So the number ordering of the two products of the two phase of light is the just changes in the binary term because the A minus and the B plus that should be the B plus and I minus in the ordering, but other three terms are same. But in the Dyson expansions, that was some of the time doing sort of the product of the two bit operator for the satisfy the causality. So was used some of the time should be the acting is the burst. So in the past times acting on the burst and the future times the past acting is after and the axial and the y is the converting guys. A should be the act burst and the next that the B is the B at the y after that. So we choose the origin is the order is the time orderings, but we want to change the orderings to the numerous orderings. The difference of the time ordering and numerous ordering is very important to calculate about some of the products of the bit operator. So in each case, actually is after the was used or was used is after the stocks used. The difference of the time ordering and numerous ordering is given like that. So the minus plus and plus minus is such a minus things, and it can be summarized by the commutator relation. And that is the same with the definitions of the Feynman propagators, which is the actings on the vacuum side or the products of the based right test with time ordering. So the result is the difference of the time ordering and the number ordering is equal to the Feynman propagated and is equal to the contractions. So which is noticed as some of the connected lines from the bit operator A and B. So it is because of Wick's theorem, which is the time ordering of the products of the base brightest and the number ordering, and that such a difference of the time ordering number ordering is equal to the all positive contractions. And if there are no contractions terms remains, then that will be used at the zero sum because there will be some of the remaining number ordering terms, and it will be given some of the zero vacuum expectation values. So all positive, all the bit bright should be the contracted, such that the number of the products of the builder byte should be the evens, not evens, not odd. So we can induce about some Feynman rules from the list Wick's theorem. So for example, in the Piper theory, the perturbing Hamiltonians given like that. There are also 4 pi, and there are some of the all positive contractions are given like that. If there are pi 1, pi 10, pi 3, so which is the representation of pi b's at the axons x, 3, x, 4, then there are the all positive contractions is 1 and 2, 3, 4, and the 1 and 3 and 2, 4, and the 1 and 4 and 2, 3. That's the representation here. And other terms are just the zeros because of the zeros vacuum expectation values from the number ordering. And if we expand it to the as matrix, then we can extend the Feynman diagrams devised through the other definitions of the as matrix coming from the solutions of the time evolution unitary separated interaction pictures through as a time dependent division. There will be some of the first terms or the similar second terms will be appears as a series of the exponential vector. Now we can define sort of the amplitudes. If the as matrix is the acting on the initial state and the balance set as a bracket. And there will be some contractions between the some bits of light will disappear. First of all, there will be some of these vacuum signature side and vacuum binary side, and there will be some of the creation and annihilations of light will be acting through such a vacuum side. And it is assumes that the free theory because the times is the infinity part and the infinity future. And if there are some contraction between the fields in the Petrine Hamiltonians, then it will be the propagator. We already stood up. The contractions of the two is the light is it becomes the Feynman propagators and is the called internal lines in the Feynman diagrams, and it is represented the internal lines of the Feynman diagrams, and the contributions to the amplitudes is the propagator, and it is called that offshore because that is a virtual particle. But if there are some contraction between the base operators and the creations through annihilation operator, then it will be the external field with the plane waves. And it is called that the onshore, which is the realistic particle. And there will be the addition all possible contractions will be the contributes to the amplitudes. And we can do the corresponding diagram. As a more specific example, we will consider the core interactions. The interaction Hamiltonian is given like that. There will be some of the coupling constancy and the two spinors, psi diagonal, psi, and the pi. So Feynman diagrams can be drawn like that. There is the psi digits, and the pi. And such interaction products will be appear. And in the second order terms, let's consider that 1 plus 2 to the 3 plus 4 scattering, 2 from 2 by 2 scattering. So that there will be the two creations of lighter in the initial start and the two annihilations of lighters in the binary state. There will be some psi digits, psi and the pi as the base of lighter, and also additional bit of lighter start from the expansions of the exponential. And there will be some of the various possible contractions. There will be the represent like that. And we can represent the T channels three level Feynman diagrams, which is 1 and 3 as a buttocks and 2 and 4 as a buttocks, and there will be the internal propagators between the pipes. It represents that there are some propagator terms and some of the external lines and some of the buttocks will be still here. Then we can also draw sort of the other channels. For example, there will be the U channel, which is the 1 and the 4 and the pi piece as a some of the buttocks and 2 as 3 and the pi piece as the buttocks. And there will be the internal propagators between the pi. Also, we can draw sort of the channel Feynman diagram. 1 and 2 has buttocks and 3 and 4 as the buttocks. And there will be some of the propagators of these internal lines of the pi piece. And that's a very simplistic diagram for the 2 by 2 scatterings in the tree lava. And we can define sort of the Laurent invariance amplitude. First of all, we know that the S matrix which is coming from the time evolutions of light test with the infinity past and infinity future. And there will be a small unity term with there are no interactions for this unity. And there are some of the remaining part which is called T transition. And if we acting through the S matrix, acting through the initial and the final size, we can find the amplitude. But if we acting through the transitions on the initial and the final side, we can find sort of the invariance amplitudes, especially the Laurent invariance. The vectors will be a piece, which is some momentum conservation and some things. And if we secure sort of this invariance amplitudes, then we can obtain sort of the observable quantities, which is decay lateral and closed auctions by the Bernoulli's golden rule. And we can calculate sort of the invariance amplitudes with the Feynman diagrams and the Feynman rules. And that is a very important big regime sort of the contemporary theory, how to obtain sort of the matrix of amplitude from the Feynman diagram.